Hi, everyone, and welcome to episode 782 of People Behind the Science. We're looking forward to revisiting our interview with Dr. Philip Moriarty today. Listeners, Philip is a nanoscientist who does some very cool research imaging and moving single atoms on different surfaces. His group's goal is to develop methods for computer-controlled manipulation of matter and 3D printing, where you can build materials and objects from individual atoms. And in our interview, Philip talks more about his research, some of his favorite scientific memories, life outside the lab, and more. So I hope you enjoy this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to People Behind the Science. Today, I am happy to introduce you all to our guest scientist, Dr. Philip Moriarty. So, Philip, welcome to our program. How are you?
Thank you very much, Maria. Delighted to be here. I'm looking forward to this a great deal.
Excellent. Well, we are excited to have you with us on the show. But before we jump into all the details about you and your work, I'd love to take a moment here to introduce you to our listeners. So listeners, Dr. Philip Moriarty is a professor of physics in the School of Physics and Astronomy at the University of Nottingham. In addition, he's an avid contributor to the 60 Symbols YouTube video project and author of the book When the Uncertainty Principle Goes to 11, or How to Explain Quantum Physics with Heavy Metal. Philip received his Ph.D. in physical sciences from Dublin City University, and he conducted postdoctoral research in physics at the University of Nottingham before joining the faculty there. Over the course of his career, Philip has received a number of awards and honors, including the 2016 Kelvin Medal from the Institute of Physics, awarded to the 60 Symbols Project for innovative and effective promotion of the public understanding of physics. And Philip was also winner of the 2015 I'm a Scientist, Get Me Out of Here Terbium Zone contest. And in our interview today, Philip is going to share more about both his life and his science. So Philip, we want to start first with life outside of science. So can you tell us how you spend your free time?
Let's get this one out of the door as soon as possible. So I'm a massive heavy metal fan. I listen to rock music, to a wide range of different genres. I play a couple of instruments, largely guitar. My instrument of choice at the moment, though, is something called Aerodrums, a fantastic instrument which is basically a completely invisible drum kit, whereby you take drumsticks and you put reflectors on the end, and then you have basically what look like bicycle reflectors on your feet. And then there's a Kinect camera and a bright light source, and it translates the motion of the drumsticks by tracking the light paths and converts that to sound samples. So it was developed by a couple of ex-Ph.D. students now at Trinity College in Dublin. I'm not on commission or anything. I'm very evangelical about this because for those of you who want to learn drumming, it's a wonderful instrument to get into. £100 and you can really get very close to a real drum kit.
Takes up less space too, right?
Much less space, yeah.
Well, awesome. Great to hear a little bit about what occupies your time when you're not at work. I have to ask, do you have a favorite band?
I do. My favorite band is Rush.
Excellent.
They're almost like the biggest cult band there is. Unfortunately, they disbanded recently, but they had a 40-year-long career, and I got to see them quite a few times on various tours. Wonderful band.
Well, Phil, great to get a window into life outside of science for you, but I do want to talk about your scientific side next. So how do you describe your work to someone who's not familiar with it?
So what I would describe myself as is a nanoscientist. Our research focuses on imaging single atoms, moving single atoms, or as I like to put it, picking, prodding, poking, pushing molecules and atoms around a surface. What we're really pushing towards is computer-controlled manipulation of matter. And ultimately, what I'd like to see, perhaps before retirement, but that gets ever closer, would be, can we do 3D printing with atoms? Can we, for example, have a computer system where we feed in a blueprint to build some particular structure from the individual atoms upwards, and to put that in place. And the tools that we use to do that, or the key tool that we use, is something called a scanning probe microscope. So it's a microscope like no other, no optics, no lenses, no mirrors. And instead you have a sharp probe that you bring in close to a surface, move it back and forth, measure some type of force or interaction. And from that you build up an image. But as well as being able to image, if you push the probe a little bit closer, you can start to modify matter, and you can modify matter all the way down to the single chemical bond limit. So it's exciting and it's fun.
Well, this is remarkable work, and I look forward to chatting more about it in our interview. And I think the research in and of itself can be motivating for a scientist, but I love to hear a little bit more about what motivates and inspires the people we feature on our show. So do you have a favorite quote or a saying or something that really keeps you going in every day?
It's interesting. So being Irish, perhaps I'm slightly more cynical in some respect. Sometimes I get a little bit frustrated by those TED Talks which are, if you do these 5 amazing things, then your life too can be amazing. I do have a few quotes, but actually they're related more to song lyrics because music plays such a big role in my life. It's largely song lyrics, and one that I really like, unfortunately, is by Rush again. Rush might crop up quite often, I hope not too often, but it's, if you choose not to decide, you still have made a choice. And there's another one which is, cast on this unlikely role, ill-equipped to act with insufficient tact, which I find myself thinking about often. So those are 2 Rush lyrics. The other quote that I like, I wouldn't say it's quite inspirational, but it certainly makes me giggle every time I think about it, is actually perhaps a little bit more literature focused, and it's W.B. Yeats. And the quote is, being Irish, he had an abiding sense of tragedy that sustained him through temporary periods of joy. So as I said, cynicism is sort of a major part of my life.
It's pervasive.
Yes, exactly. Yeah.
Well, thank you for sharing some of your favorite music lyrics and a quote as well. And I'd love to hear a little bit next about some of your favorite people in science, or whether they were maybe particular motivational figures or mentors who really had a big impact on your career.
Absolutely. My Ph.D. supervisor, for one, and actually towering above all others, a guy called Greg Hughes. So what was great about Greg is, well, he inspired me in terms of moving into a career in science, becoming a lecturer myself. And that was because, like so many things, he trusted me. And it really wasn't a sort of mentor-student interaction. It was an interaction very early on of peers. And we'd argue about things. We'd spend a great deal of time saying, we should do it like this. No, we should do it like that. No, we should interpret the data like that. And that was really coming from a student experience into that type of experience where your ideas are treated seriously and you're debating and discussing and arguing about them. That made a big impact on me. And in terms of trying to emulate what Greg did, that's something I do absolutely look back on with great fondness and try to repeat when it comes to the interactions with the students in the research group here at Nottingham.
I love it. Well, it sounds like you've had a great experience in terms of the mentoring relationship with your PhD advisor. And I understand that mentoring and public outreach is a big part of what you do now. So can you speak a little bit about your experiences and maybe your dedication to this area?
So we're involved in a number of different things. The major one is something called 60 Symbols, which is a YouTube channel, which you mentioned right at the start in the introduction, set up by a guy called Brady Harron. So Brady used to be a BBC video journalist, and then about 10 years ago, he struck out independently, set up a number of channels. One of the first was something called Periodic Videos, which is our colleagues here in Nottingham, just across the way actually from where I'm speaking, which is a video based around each element in the periodic table. Physics looked at that. The School of Physics and Astronomy looked at that and said, well, that looks quite good. Why don't we try and do something similar? And something called 60 Symbols was born. So 60 symbols, the reason for the 60, and we're asked this a lot, is that initially we had a tranche of funding to make 60 videos. We're now up to at least 360, probably approaching 400, something like that. And they're short videos. They're not lessons. They're not tutorials. They're not classes. Basically, Brady comes along with a camera, films us. We talk about something in physics that enthuses us, perhaps a new piece of research that either we're doing or somebody else has done, or even questions along the lines of, why is glass transparent? What happens if you put your hand in the beam of the Large Hadron Collider? A great deal of fun to do. Working with Brady has just improved my teaching and my explanations a great deal, because he's not a scientist, but he's intensely interested in science. And therefore, we have to try and explain stuff to Brady that appeals at a broad level rather than just at the sort of undergraduate level where there is already some experience and some knowledge of physics. Mm-hmm. So that's a big part of the outreach we do. The other aspect is doing things like Pint of Science and something called Skeptics in the Pub, which involves, as you might expect, going into pubs and talking to people there. Mm-hmm. I really love that. In fact, I love that more than going across the world to an international conference where you stand up in front of your peers and they'll ask you something about the minutiae of the experiment. What voltage did you use here? What analyzer did you use here? You go to do one of these Science in the Pub things and you get asked questions like, why do you do this and why should I care?
Right.
Which is a much more interesting question.
Those are the hard-hitting questions, I think.
Yeah.
So now, can you take us back to the beginning, Philip, and tell us a little bit about what first got you started on this path towards a career in science?
Oh, thank you for that question. Yeah, this is a story I've told to a number of people, and it's entirely true. It sounds like it's almost too good to be true, but it is entirely true. My uncle was a radio amateur. Radio ham, as they're called. So he spent a lot of time putting up aerials on his roof and stretching them across his back garden, etc., and listening to radio broadcasts across the world and speaking with other radio amateurs across the world. This was when I was about 10 or 11. He and I built what's called a crystal radio. So crystal radio is basically just 4 components, a diode and an inductor and a capacitor and a big antenna and a little earpiece. And we set that up and I put the earpiece in and we tuned the capacitor and could hear a radio station. And I remember thinking, well, where is the power coming from? And then suddenly realizing, with some help from my uncle, of course, that actually the power is coming from the radio waves themselves. And that for me was a real moment of wow. Just sort of realizing that in the room or in the air, there were all these sort of electromagnetic waves that were, I mightn't have explained it quite those terms when I was 10, but that's with a bit of hindsight.
Sure.
That really made a big impact on me. And I thought that's remarkable. And that interaction with my uncle and thinking about electronics a little bit and thinking about physics in that way really made a big difference. Then I got into computer programming. A long time ago, early 80s, so a thing called the ZX81, then something called the ZX Spectrum. Really got into programming quite a bit. But in the end, decided to do a physics degree rather than a computer science degree, but then spent the first 2 years of my physics degree going, maybe I should have done a computer science degree. And my mantra throughout, because I am not a very good mathematician and maths is pretty important for physics, was if I can't code this, I don't understand it. So I try and translate maths into computer programs and algorithms and get an understanding that way. And then I was not a particularly good student, but in the end did enough to get a sufficiently high degree classification that I could go on to do a PhD. The year I graduated from my undergraduate degree was the year that a very important paper was published by a group at IBM Almaden. I never know how to pronounce that, on the West Coast.
Sure.
Research labs who, for the first time, pushed atoms around, manipulated individual atoms, and they spelt out the IBM logo, which is a very good thing to do if you find out you can manipulate matter for the first time at the atomic level, is to spell out the name of the company that employed you.
It's good for marketing.
Absolutely. But that made a huge impact on me. And then when a PhD was advertised in that general area, I leapt on it and haven't looked back since.
Wonderful. So did you kind of know then at that point that you wanted to be a professor, or were you considering other career paths? How did you get into this academic track?
I certainly knew that I wanted to be an academic. I thought there's no way that I'm going to be good enough to do that, but it's something I really wanted to do. So I pushed on and then became a postdoc here in Nottingham. And those postdoctoral years, due to the wonderful support here within the group, meant that I got a lectureship fairly soon after that, so 97. And then I just stayed in Nottingham because it's a wonderful place to work. I don't want to turn this into an advertisement for Nottingham, but it is a great place to work. But even 6 months into my PhD, I was thinking, I love this. This is what I want to do with my life.
Well, that is awesome. And I know you're working on so many cool projects right now, Philip. So is there one in particular that you want to tell me and our listeners a little bit more about?
What I'm really excited about, and actually did a video for one of Brady's other channels, something called Computer File, recently about this, is the interface between machine learning, artificial intelligence and nanoscience. In particular, what we do, our stock in trade really is image analysis, and machine learning is getting a lot better at being able to distinguish between different images. At the moment, the way it works for the vast majority of groups, and ours is no different, is that you have the sharp probe, you bring it in close to a surface, you make an image. However, the problem is that the sharpness of the probe and the structure of the probe is absolutely crucial. If you change that structure a little bit, then the whole image quality will change. So what we do, generations of scanning probe microscopists have done this, is if you don't get the atomic resolution, you don't see those atoms, then what you do is you might apply a little voltage pulse to try and jiggle the atoms around on the probe, or you might push it into the surface quite gently. Then you might get a little bit frustrated if things aren't working and you push it in a little bit further up until the point an hour later where you're digging the probe into the surface as much as you can and wobbling it about in desperation. So that's happening very much on a trial and error basis in many groups. And it's a massive bottleneck in terms of the science that you can do, because you need to get that very highly resolving, close to perfect tip. If we can train the microscope to recognize when it's got a good image, then what we can do is just press a button at night, go home and come in the morning, and the probe's in the right state for us to start the experiment proper. And that's a real emerging field now, is linking together machine learning with scanning probe microscopy. It's something we've been working on a little bit over the last few years. A group in Canada led by a guy called Bob Walco recently published a really important and exciting paper in that area. So yeah, I'm very excited about that.
So what makes a good image?
Now, that is a really good question. In terms of at the moment, is that you can take a number of different scanning probe microscopists and sit them down, and some will think, well, that's a pretty good image, and others will think, no, we can do much better than that. So actually, when even humans can't agree, then trying to train a neural net or trying to train the machine system to recognize a good image is pretty tricky. However, having said that, there are some certain things in terms of, do you see periodic features? If you're expecting to see an atomic lattice, do you see periodic features? What's what we call the corrugation? So in terms of almost, if you think about an egg box or an egg carton, if you think of the atoms arranged like that, the depth of that between the peaks and the troughs is giving you a good indication of the quality of the probe, because if the probe is blunt, you're going to get quite into those troughs as much as you'd like. So you become fairly familiar as a scanning probe microscopist about that. There are other more changes in probe that can give rise to very sharp scratches and discontinuities in the image. So it's just trying to embed all that type of almost tacit human knowledge into the machine learning system. And it's difficult, but the fact that it's difficult makes it challenging, and therefore it becomes a very, very interesting problem.
Definitely. Well, this is a really cool project. And you mentioned you're sort of manipulating at the single atom level. What kinds of atoms are you working with?
We tend to work with silicon quite a bit. We also worked a little bit with metals, silver and gold, etc. But right across the world, other scanning probe microscopy groups work with copper, gold, silver, silicon, germanium, sodium chloride, right across the board. You do have to choose. It's not quite at the point where it's entirely universal that you can just pick some arbitrary surface. That's not how it works. And certainly you really need to work with quite flat surfaces, atomically flat surfaces. But in some cases, it literally is child's play. The example I like to give is that last year, my son, Fiacre, who was 8 at the time, spelt out the letter F for Fiacre by pushing silver atoms across the surface.
Oh, wow.
And he's 8.
Yeah.
So it really is at that level in some cases. For other systems, it's much more difficult. But once you've got that level of control that a child can do it, then it's interesting to think about, well, if we do hook this up with the artificial intelligence system, where could we go?
Absolutely. And Philip, you've mentioned some of the challenges that you face in the research that you do. And I think talking about the challenges, the struggles, the failures in science is so important. So do you have a story of your own of one of these big failures or major challenges that you've faced that you can share with our listeners today?
I'd like to talk not so much about a failure on the research side, but failure actually on the student side, because as in many countries across the world, universities in the UK, and Nottingham's no different, are seeing a lot of students having increasing levels of mental health problems. And where they're incredibly driven and they fail, the bottom drops out of their world. That's the end of everything, and they don't know how to recover. So I was not a very good student. I failed my third year very, very badly in that I had to repeat the entire thing. And that's largely because I was focused rather naively on trying to be a rock star at the time. So playing guitar and being in a band and emphasizing that over actually studying and doing my exams. However, if I hadn't have failed those exams, so it was a 4-year degree, I'm 100% certain I would have drifted through my 4th year, graduated with a much poorer degree than I eventually did, and would not have got a PhD. I failed those exams. That gave me a massive kick in the
behind, right?
I'll watch my words, and really made me realize that actually I was screwing up. And that was very, very important. That failure was incredibly important, actually determining the rest of my life. So it's how you respond to failure that's the key thing, obviously. And research, it really is a succession of failures, which makes the rare occasion when everything does work so much nicer to actually be able to celebrate a success at times. But it's something that's not appreciated, I think. And those very high-performing students who are used to, for example, going through their degree, getting very high exam results, sometimes then when they're in the lab, and sometimes when they're trying to get an experiment that nobody else in the world, or perhaps nobody else in the universe, has ever tried to get going, and they haven't been exposed to that failure, then that can sometimes be difficult for them to realize, well, actually, I've been at the top of the class the whole way through, but suddenly now I'm not. Suddenly this won't work. I think failure is very, very important in terms of just setting in place that tenacious mindset that you really need for science.
Absolutely. And I think you really brought up some important points in this response here. But I think in hindsight, sometimes it's easier to say that, oh, this failure was helpful looking back. But in that moment, how did you recover, Philip? How did you turn things around?
When it came to those exams, I was absolutely distraught, though I should have seen it coming. I didn't turn up for 2 exams. Mm-hmm. There was no way it was not going to happen. Right. But yet at that moment when you felt, right, okay, I've failed, the bottom's dropped down, what am I going to do? What am I going to tell my parents, etc.? But it was a question, okay, well, I've screwed up. How do I fix this? And there was only one way to fix that, was just try and do my absolute best. I'm not suggesting that's a good life strategy. I wouldn't wish that 4th year I had to do on anyone, because we carry a certain percentage from 3rd year into 4th year in terms of deciding our final mark. But it's a sheer bloody mindedness, I guess. And that does count for a lot, I think, in terms of science. I'm not the most intellectually equipped, but I am fairly stubborn and I am fairly pig-headed. So
those aren't bad traits to have, I think, in science. So.
In science, maybe not elsewhere.
Right. Well, Philip, thank you for walking us through one of these difficult times in your own career. I think it's so important to share these lessons with our listeners out there. But we don't just want to dwell on the difficult points for you. I'd love for you to tell us next about one of these happy success moments in science.
This is a small thing, but it is an important thing. So we can go out as scientists, we can disseminate our work, we can stand up in pubs or whatever forum we like, and open day talks and public lectures, etc. And you present your work sort of as a fait accompli, going, look at what we've done, isn't this nice? What's a bit more fun and a bit more interesting is sort of the citizen science aspects, where you actually get the public. And I know sometimes public and publics can be patronizing terms, but you get the public involved in the work. And one thing we did a number of years back via 60 Symbols video was to ask for drummers to submit drum tracks, which we then analyzed in terms of the fluctuations and the correlations in terms of the beats. Now, this was based on a paper published by a group led by a guy called Esa Rasanen, who was then in Harvard. And we took that type of methodology and broadened it out to the YouTube audience and got a lot of different drum tracks submitted. And then over the last couple of years, I've worked with a number of different undergraduate students, 6 in total. And finally, we've submitted that paper to a journal last week. So I'm very, very happy about that. It hasn't got through the peer review process. It could still get rejected at this point, but at least it's submitted.
It's that feeling of relief when you push the send button, right?
Precisely. And then you see 3 errors. But
Well, that is a fantastic project. And I love that you included the citizen science element that's really drawing the public interest in and getting people engaged in your research.
I think there's a lot to be said for that. The astronomers actually have done it for some time. There's something called Zooniverse, which is a lot of those type of citizen science projects in terms of galaxy classification, etc. And we nanoscientists have been a bit slow off the mark to try and engage that way. But I think there's a lot of scope for that type of project in future, particularly, again, with the image analysis side of things.
Certainly. Well, congratulations to you and all of the people who helped make this project possible.
Thank you.
Absolutely. We talked about some different aspects of both your life and your science. And I mentioned in our introduction that you have been working on this fabulous book that's out now. So I'd love for you to chat with us a little bit next about books. So can you tell us a little bit about your book? And then if there's any other books you'd like to recommend for me and our listeners.
Okay. Any opportunity to plug the book. Thank you. So the book is called When the Uncertainty Principle Goes to 11. So I hope there are some out there who will appreciate that goes to 11 reference. My favorite movie of all time is Spinal Tap. Mm-hmm. I love Spinal Tap. As I've said, I'm a massive heavy metal fan. But beyond that, there are genuine links and fundamental links. There really are, nobody believes me, but there really are, between quantum mechanics and heavy metal, because heavy metal is a form of music, though I know some would quibble with that already, but it is. And quantum mechanics is a theory fundamentally of waves and how waves interact. And what's music? Well, it's all to do with sound waves and how sound waves mix and match and interact and how we create different chords and notes, etc. So there's already close links between any form of music and quantum physics. Heavy metal takes it a little bit further, just in terms of the way guitar's played, in terms of the way drums are played, in terms of feedback and distortion. There are so many different aspects of that couple into not just quantum physics, but physics in general. So I had a great deal of fun teasing out those different links and writing the book about them. It's something I've wanted to do for 20 years.
Oh, wow.
Yeah, I've really wanted to do it, and then finally bit the bullet. And through a really good publisher, Ben Bella, who were very, very supportive, editor Alexis Stevenson in particular, it was great for me because I'm obviously a scientist, and you get into a habit of writing in terms of science, which can be a little bit staid. There's a fairly formulaic way of putting together a scientific paper. In recent years, it has become of increasing interest, blah-de-blah-de-blah. Right. And so a lot of the excitement can get sucked out of that paper. So actually, when I was at high school, or secondary school as we call it here, I was torn between doing English for a degree or physics as a degree. So I ended up going down the physics route, of course, but still like to write, still like to blog. So was really very keen to write, but very conscious that I've been writing in this very staid scientific style for most of my life. So Alexa and another co-editor called Laura Lee, it was great for me. I almost felt like paying them because it was like an exercise in creative writing. Move this, Philip. This doesn't quite work. Shift this. You need to create a different atmosphere. It was great. It was fantastic. So I hugely enjoyed writing that book.
Well, that sounds like a fantastic book. I'll put it out there on our website for our listeners to find. Are there any other books that you'd like to recommend for us today?
There's actually quite a few, but over the last year alone, I was thinking about this. A few of my favorite books include something called Inferior by Angela Saini. Actually, I've got a copy here. Just let me read the blurb on the back.
Sure. This
is from a guy called Adam Rutherford. Angela Saini has written a powerful, compelling and much-needed account that challenges deeply rooted preconceptions about sex differences, some blatant misogyny, others buried in 1,000 years of patriarchy. Inferior shows that both are fundamentally flawed and beautifully illustrates how science is just beginning to tackle this staggering imbalance. And then the other quote is, an immensely readable and compelling book providing up-to-date and evidence-based ammunition for readers who want to rebuff tired myths stereotyping men and women's brains and bodies. It's a fantastic, fantastic book. I can't recommend it enough. The other one I really liked is something called The Death of Expertise by Tom Nichols. Unfortunately, one of the students has borrowed that, which I thoroughly recommend. And similarly, the other one by actually probably my favorite science writer is a guy called Philip Ball, which is called Beyond Weird, where he looks at the various and many interpretations of quantum mechanics that there are and sort of teases them out, but in incredibly well-written prose. He combines clarity and punchiness. He's, as I say, just about my favorite science writer. So those would be the three I'd recommend.
Excellent. Well, you have given me and our listeners a lot to add to our reading list, so we will have to get busy with those. I will put them out on our website, like I said. And one of the aspects that we haven't yet really touched on, Philip, are some of the opportunities that you've had as a scientist to travel. And I think this is one of the things people get really excited about when they learn that this is part of the career. So do you have a favorite place when you look back that your science has taken you?
In the early days, absolutely. The sort of travel aspects were key. My children came along and they were growing up. I certainly curtailed the amount of travel I did. But what's interesting, what still sticks in my mind, and this was harking back to, I mentioned Greg, my supervisor, but the very first conference I went to was, a major conference was in Chicago. And that was also the very first time I was in the US. Now, I come from the heart of rural Ireland, where our nearest neighbours, if you discount the cows, were about 2 miles away.
Oh, wow.
So coming from that environment, I spent some time in Dublin, which isn't quite as rural as that. But I've always been drawn to big cities and I loved Chicago so much. So for that reason, because it was a great conference, it was my first time speaking at a conference and also being the first time in the US. The other thing I really enjoyed, and again, it's the US, was last year something called SciFu, which is something held at the Googleplex in Mountain View. And that involves not just scientists, but so many different disciplines. There were physicists there, biologists there, chemists there, people involved in psychology, neuroscience, but also authors, poets, artists, sculptors. all basically put together. There's no conference agenda or program. What happens is on the first day, you stand up, you describe yourself in one sentence and 3 words, and then you just get together with people, and the conference program appears organically, let's put it that way. And it's great. You get to speak to people so far outside your discipline and so far outside any other experience I've had. It was absolutely fantastic.
Describing yourself in one sentence as 3 words is hard. Do you remember what you said?
Nanoscience was in there. Coffee, possibly always over enthusiastic or something like that. I can't quite remember what it was, but yeah, it wasn't the most serious. Coffee was certainly in there. I drink far too much coffee.
Coffee's important. I love it. Well, it sounds like you had a great experience. I think being from the US myself, I take for granted that we've got some cool places to visit here. So.
You do, definitely.
Well, throughout our conversation, you've talked about some of the great people that you've had a chance to work with over the course of your career. And I think the people in science are fantastic, but that's not always the reputation that we get. So I love dispelling some of the myths and stereotypes out there by sharing some of the fun and funny memories and experiences that scientists have. So, Philip, do you have a quirky tradition or just a funny or fond memory that you've shared with colleagues that you can tell us about today?
Unfortunately, again, it's related to the music side of things.
That's not unfortunate.
Good. I'm glad you feel like that. I certainly do. So if you have a Venn diagram of physicists and heavy metal and heavy rock fans, it's a fairly large overlap, I would say. So we have a culture of musicians actually coming through the group. So we've had a number of different jam sessions. And the other aspect of that, when you say physicists and scientists are sometimes seen to be quite dour individuals, and it's really such a shame because we certainly are not. The other aspect, and it's particularly difficult here in the UK because with the high school system in the UK, it's different from the US and it's different from in Europe, where students tend very early on, by the age 16, to specialize either in terms of the arts and humanities or to specialize in terms of the sciences. So we'll see many students doing A levels, for example, who will have physics, further maths and maths. That will be their high school subjects.
I see.
And the last time they'll have written an essay might have been when they were age 14 or 15.
Oh, wow.
So that sets up this divide between the arts and humanities and STEM, which is really, really unfortunate because there are so many links. The quote I really love is by Leibniz, who was Newton's competitor when it came to calculus. Leibniz developed calculus independently of Newton, and they had massive battles in terms of who had the intellectual priority. But he's very interested in music. He's got this wonderful quote, which is, music is the human brain counting when it doesn't know that it's counting. So that there is deep links between maths and music. And so many musicians I've seen in not just the Nottingham group, but so many other groups across the world, very, very accomplished musicians. It is a shame that we're painted like these automatons sometimes. And I quite like the Big Bang Theory. My daughters certainly love the Big Bang Theory, but it's a little bit of a shame in terms of the stereotypes it paints sometimes.
Absolutely. And I think that's one of the main drivers of our show is to display to the public that scientists are these multifaceted people. You have other interests, but you are really passionate about what you do as well.
Yeah, that's true of so many science. It's very difficult. You get that result at 4 o'clock in the morning that you've been working on for so long, and you know that maybe you're the first, as I say, in the world to see this. You're not going to sit there and go, oh, good, another result. You're going to jump up around the lab.
Right.
It's frustrating that those stereotypes take so long to get removed from the public consciousness. But having said that, I think it's happening. Every scientist isn't seen to be the white-coated, fuzzy-haired icon.
We can be cool.
Yeah, we can be cool, absolutely.
Well, in terms of talking about your research, I know you're working on some amazing things. And I think as you're going through these projects, there are always so many more things that you want to do than often you can do. And some of the limitations might be funding or staff or technology or feasibility. But I feel like every researcher has just a few of these questions, their dream questions that they've wanted to ask but haven't been able to. So, Philip, I want you to tell us today, what is the big question that you've been dreaming of answering but haven't been able to?
My first one as a big Doctor Who fan is, can we build a TARDIS?
Ooh.
Can we build something that travels in time and space like a TARDIS does? That's my first major question.
Mm-hmm.
The other one would be, are we living in a computer simulation, which is the perennial question. That would be a good one to target if feasibility isn't an issue.
I like these sort of science fiction questions.
Yeah, I'm a big science fiction fan. So Douglas Adams in particular.
Awesome. So fantastic questions for me and our listeners to ponder today. And of course, the feasibility often gets in the way. So that is a bit of a challenge in science.
Yes.
And we've talked about some different aspects of your career. And one of the things that I would love for you to do, Philip, is for our listeners out there who might be starting their own scientific journeys, do you have a piece of advice that you can give them, perhaps one that really helped you along your path?
One thing I remember in terms of lecturing, at least, is a very well-loved lecturer who's now retired, a guy called Roger Bowley, here in Nottingham, came along to do peer review of one of my first lectures when I started as a new lecturer here back in 97. And what he said to me at the end was that you speak at the speed of thought, try to slow down. And he's absolutely right in that I'm often halfway through a sentence before I have any idea where it's going and end up like I am now, struggling to work out how I'm going to get to the end of the sentence. That was a piece of advice that I really wish I could follow. And I've seen some people who've got a real skill who can avoid what I just did there, who can get through a whole sentence or a whole paragraph or speak for an hour and be very, very eloquent without the and ahhing. And much as I'd like to say that everything is down to, even in science, everything is down to the substance of what you say, unfortunately, it's not like that at all. An awful lot of it is down to style and presentation. And you might think that you can get away with just sitting in your room, doing the mathematics, publishing your paper. But even if you're doing the most theoretical of physics, you're going to have to get out there. You're going to have to talk to people. You're going to have to stand up at conferences. So don't neglect the sort of presentational side of what you do. That's difficult for some physicists, including myself, because we tend not to always be the most extrovert, let's put it that way. But those sometimes referred to somewhat scathingly as soft skills, but those soft skills are important. And again, the ability to write, sometimes physics is just seen to be applied maths, which is entirely wrong, but sometimes it's seen to be that. Mm-hmm. That's not it at all. I would say that 65% of my time, at least, is spent on words rather than numbers as a professional physicist, as I sometimes like to consider myself. The other thing is, I'm admissions tutor, so I'm responsible, along with a couple of colleagues, for overseeing applications to our physics degree programs. And one thing students always ask is, well, what kind of a job can I get out of this at the end? And that's a valid question. And in the UK, they're certainly paying an awful lot of money for the degree, so I can understand that. But just let your enthusiasm, let your interests be the key guide. Because if you go into particularly a physics degree with the idea that I'm going to come out of this and what's driving me is the money I'll get in the end, it's an intellectually challenging degree. There's going to be downsides to it and difficult times. And if you're doing it without a real love for the subject, then perhaps it's not the best degree for you. But that's true for any subject, I would say. So those are the pieces of advice I'd give. I don't like offering pieces of advice because I certainly don't have an infinitesimal fraction of the answers, but those are my thoughts.
I think you can give advice without having followed it yourself, too.
Good point.
I love this presentation matters point that you brought up, though, because this is one of those things where it's the hardest thing to change as you're going through graduate school, because those communication skills is something that's been developing over the course of your whole life. And then you get to this point where you feel like you have to break all these bad habits. And I know the feedback I always got in all of the lectures I taught as a graduate student was I speak too quickly when I'm excited. So you can clearly see I still do that.
And I have an awful habit of wandering around as well. The other thing is the accent is an interesting one. I got lots and lots of comments on the accent when I first started. Actually, I remember teaching my daughter how to count. So my children are born and bred in Nottingham, and counting 1, 2, 3, 4. And she goes, this was when she was 3 or 4. No, Daddy, you don't mean 3. And she pointed out the window and said, that's a tree, Daddy. You mean 3. Listen. And I was not conscious of that. The students had picked up on that a couple of years before that, but I was not conscious of that. And I'm deeply conscious of that now in terms of how I pronounce those THs. So it is interesting how particular presentational tics, and because I drink so much coffee, I move around an awful lot as well. But they all, in many circumstances, more so than what you're actually saying, those are the things that influence people. And what you say, you're sort of over-enthusiastic, and I share that as well. But having said that, if you go out and you tell certain audiences with enough enthusiasm that the earth is flat, they'll believe you. So,
unfortunately.
Yeah, style over substance, unfortunately, is a real thing.
Certainly, but great advice for our listeners out there. And can you tell them if they have loved what they heard today and they want to learn more about you and what you do, Philip, where can they go to learn more?
So if they're suitably masochistic like that, so there's, as I say, the 60 Symbols channel, I work with Brady Aaron quite a bit on that. I have a blog, which is a bit of a long, wordy, unfortunately not the shortest of URLs, but it's Moriarty, MUIRCHEART blog, BLOG, all one word, .wordpress.com. The Moriarty comes from the Irish for my name is Moriarty, so that's where the Moriarty bit comes from. Very happy if they want to go there, or alternatively, and most easily, just email me at philip.moriarty@nottingham.ac.uk.
Perfect. Well, listeners, definitely get in touch with Philip if you have any questions. And I do want to give you one last opportunity, Philip. Was there any other last message or anything you wanted to leave our listeners with today?
Just to realize if I get nothing across other than that point that there are deep links between heavy metal and quantum physics, I'll be very happy, because quantum physics is seen to be very intellectually challenging and conceptually challenging, and it is. Heavy metal is not seen to be particularly intellectually challenging, so I like that juxtaposition. So if I get nothing more than that across, I'll be very, very happy.
Excellent. Well, listeners, definitely keep that in mind. Philip, thank you so much for joining us on the program and sharing a piece of your story.
Thank you so much, Marie. It's been a huge pleasure. Thank you.
Well, it's been fun to chat with you as well. Listeners, great to have you here with us as always. We'll see you next time on another episode of People Behind the Science.